have reached the end of our unit, and for all intents and purposes, the end of our year. This will be the last objective that we covered, and it's the one that we've been building to this entire time, which is actually how do we use parabolas in the real world, right? What's the context of parabolas? And so everything that we've done prior to this, solving for the x-intercepts, finding a vertex, axis of symmetry, talking about the y-intercept, the fact that parabolas are symmetrical, it's all been building to using parabolas in a real life context. Okay, a real life context. So, being the gentleman that I am, here's a brief review of the things you'll find helpful for CO60. First of all, sketching a graph. How to tell just by looking at an equation whether the parabola is opening up or opening down. How to calculate the y-intercept very easily just by looking at the equation, things like that. Getting a general shape of what the parabola is supposed to look like. The y-intercept. How do you identify the y-intercepts given an equation of a parabola? 0c. Okay? 0c. Now, more importantly, the context piece here, what does the y-intercept of a parabola represent? And we haven't talked about this. I mean, it's where the parabola crosses the y-axis, yes. But in context, okay, in context, it is oftentimes the initial value. When you see this word initial, doesn't look like value at all there. You're probably wondering what that word is there. When you see the word initial, it is most oftentimes talking about the y-intercept. Okay? Because with parabolas, that x-axis is very frequently the time. And on the y-intercept, what does x equal? 0. So it's kind of where you start timing something. One of the questions I'm going to have you solve for here is how high does a rocket get after you launch it? Well, at the moment that you launch a rocket, x is 0. Time is just beginning, right? We care about the y-intercept. That's how high it is at that point. Right? So when you see the word initial or begin or something like that, it's talking about the y-intercept. Paisley, question. Initial.
Oh, okay.
I've said it like 10 times now. Initial. Okay. We'll care about the vertex. What is the formula for the vertex of a parabola? You need to know this for PO54 and how to graph them. Caitlin. Negative b over 2a. Right? And remember, that just gives you the x value. Okay? That just gives you the x value. You need to then plug that in the equation to find y. Negative b over 2a is the x value only, and then that gets plugged into the original equation to solve for y. And the vertex, why is it important? What is the vertex point of a parabola? It gives us the axis of symmetry, but also it's the highest or the lowest point, right? So if your question is, how high does the rocket get? You're looking for the vertex. Okay? A rocket goes up, comes back down. How high it gets, you want that top point, vertex point. Okay? The vertex of a parabola represents the highest or the lowest point. The minimum or the maximum. Another reminder, make sure you've got a calculator for this test. Don't rely on others. They will be using it on pretty much every objective, and it'll be very annoying to have to share with someone who doesn't bring their own. Okay? Axis of symmetry. What is the axis of symmetry? How do you identify it?
Oh.
Yeah.
It's like isn't that just the middle point? Like,
It is the middle. Okay. It is the x value of the vertex. Right? It's that vertical line that passes through the center of a parabola. Okay? It passes through the x value of the vertex point. And what does it represent? It represents the middle. It's that line of symmetry of a parabola. It's that point where you can fold it in half and it'll land over itself. Okay? It has very much to do with the vertex in that way. So we kind of learned all of that in PO54, the y-intercept, the vertex, the axis of symmetry. Then we moved on to the x-intercepts. We spent like 3 objectives all about the x-intercepts of a parabola because they're pretty important. What are all the ways that we've learned to find the x-intercepts of a parabola? What if our equation is ax squared plus c equals 0? What's the method? Opposite operations. Whoever's humming.
It wasn't me.
Shh. I didn't ask. I just said whoever's humming. That is enough. Okay. What if your equation is in ax squared plus bx form? What's our method to use here? Nathan.
Negative b over 2a.
That's for the vertex.
Wait, there was one where it was like, negative b over a.
Okay, but that's when we get down to our solution.
But like, you could just take shortcuts.
There are shortcuts available, yes, but it's the GCF method. And what Nathan is talking about, that negative b over a, the opposite of your constant divided by the coefficient, that's what you can use when you get your answer down to this ax plus b form, right, to solve. You can also do it from the original equation in this form. Okay, but it's the GCF method that we first talked about. What if your equation is ax squared plus bx plus c equals 0? All 3 terms. Factoring.
Or you could do the little.
No shortcuts, Nathan.
No, you could do the other one.
There's nothing little about the quadratic formula, but the one that works for all of them, to where if you only remember one thing on how to solve for the x-intercepts, that one thing should be the quadratic formula.
You should have like
Okay?
Yeah, why couldn't you
just tell us at the start of the game?
Because you've got options. The quadratic formula is not very efficient. 11 people didn't do their homework. I don't know if those 11 people or those who did your homework understand this, right? And so if you don't, you've got other options, okay? Sometimes you have to use the quadratic formula because if your equation is not factorable, Brielle, put it away, wherever it is, okay? But it's not a very efficient way. It's time consuming, and there's a lot of areas for mistakes, okay? So will it work? Yes. But it's not the most efficient way. And then what do the x-intercepts of a parabola represent?
I was going to say x.
Okay, so oftentimes with parabolas, we said the x-axis is usually time. The y-axis is usually height. Just when you are talking about parabolas, something goes up, something comes down. The y-axis is usually going to represent height. And so the x-intercepts, they're on the x-axis. What would they represent in context if the y value is the height of a rocket or a stream of water or whatever?
Time.
Base.
What is...
When you started and where it ended.
Not so much where it started, where it ended, kind of. It's not going to be time because we're talking about when y is 0 here. Colin? The ground.
What?
Okay?
Well, like ground covered.
Right? If you are, one of the questions here is you kick a soccer ball and you want to know how far it was kicked. Well, if it starts on the ground, you kick it and it lands on the ground again, right? The x-intercepts of the parabola will tell you when it's on the ground, where it starts and where it lands, okay? So the x-intercepts, they oftentimes represent the ground because usually in context, y is going to be height. And when y is 0, that's a definition of an x-intercept. When the height is 0, it's on the ground. Okay? Paisley.
For this test, are all the objections going to be zeros?
Yes.
Even
said that 20 times.
I think we need this question.
Yes, I did. Thank you for coming to my defense. Okay, let's start here.
I don't understand.
Situation number 1. We got Michael here. Michael points a garden hose upward such that the stream of water follows the path, of negative 16x squared plus 32x plus 5, where x is time and y is the height of the water in feet. Okay, so we're given the equation of this parabola, and from this we are expected to answer all of these various questions. Okay, the first one: sketch the parabola representing the stream of water. Okay, well, here's Michael.
Do we have to draw it?
No. Okay.
So might be on me.
But he's holding this hose, and the stream of water is following the path of y equals negative 16x squared plus 32x plus 5. So I'm going to make my axis here. Here's the y-axis. Here's the x-axis. Okay? The y-axis, like we've talked about in context before, height, and then the x-axis is time. X is time in seconds, and y is the height of the water in feet. Now, if he's holding the hose, that's where the water starts, right? Wherever he's holding the hose. So, and then based on this equation, what direction is the parabola open in? Down, which makes sense, right? If you're holding a hose, the water's going to shoot out and then come down, okay? So a general sketch of this parabola might look something like that. Okay? We're not looking for perfect accuracy here. We're just kind of giving a general idea of what this looks like. You're holding a hose, water comes out, it's going to look like that. Okay? Now, letter B. What is the initial, I didn't cover up the word, what is the initial height of the stream of water?
5 feet.
5 feet.
So, the I need to here is what you're looking for.
Y-intercept.
We're looking for the y-intercept. Okay? We talked about that word initial being where things start, and now that we can see this in context, it makes sense. When he's holding the hose, x is 0, right? Time hasn't started yet. When water first flows out, Paul, it's going to be at 5 feet in the air. How do we know that? The y-intercept. That plus 5. Okay? Now it says, how high will the stream be after 2 seconds? Which variable, x or y, does the 2 seconds represent? And how do you know that? It's talking about time. Okay? So, what you need to do is plug 2 in for the x variable. Because if y represents the height, and you're given the time, by plugging 2 in for x, you'll be calculating the height of the water after 2 seconds. In context, 2 seconds is right about there. We're looking for the height of the water, right, after 2 seconds. Okay, I probably shouldn't have written that in there until we have more idea of the value, so I'll redraw this while you calculate. Erase. Okay. So what do we have? We have this. Get this, get this, time, right? So, our equation, y equals negative 16 times 2 squared plus 32 times 2 plus 5. What do we get?
5. So maximum height is
Anyone not get 5?
no.
Okay.
Wait, let me write the equation down.
Now, I just heard someone say, now the maximum height is 5. Do you know that 2 is the vertex?
No, our parabola's wrong.
Why is our parabola wrong?
Because it has to be like straight, because if it's going up, that means he was pointing it up, but the maximum height was where he started.
Are we finding the maximum height here?
No.
Finding it out.
Does it say what is the maximum height? No, it says how high is it after 2 seconds?
It's still wrong either way, because after 2 seconds, I don't think it.
Okay, so we know it's 5 feet when it starts, right? Because that's the y-intercept. If it's also 5 feet after 2 seconds, remember what goes up must come down. Okay? So after 2 seconds, the water goes up, but then it comes back down again. It's the same height after 2 seconds as it was when you started because it's on its descent now. Okay? It's on its descent now. Anyone not get phi for this, plugging this into their calculator? Because that's going to be pretty important. Okay. Now, what is the maximum height of the stream? What are we looking for now? The vertex. Give me a second way we can solve this other than calculating the vertex.
Oh,
Nathan.
negative b over 2a.
That's the vertex. Give me a second way we can solve this other than using the vertex.
It's at 5 feet when it's coming down at 2 seconds, so then it'd be halfway between. That'd be the reflection.
Remember, parabolas are symmetrical, right? If after 2 seconds it's the same height as it was when it started,
1 second.
in between there,
6 seconds. Was that right?
no, 6 seconds is way over here, Nathan. It's already,
6 feet.
okay? We don't know it's 1 foot higher. We're looking for the time. Stop just shouting things out, okay? If after 2 seconds it's the same height as it was when it started, it's on its descent, the Dean's saying parabolas are symmetrical. If it took 2 seconds to get to the same spot, that means that at 1 second, right, it had to have been at its highest point. Because 1 is halfway between 0 and 2. Okay? Now we can verify that by actually calculating the vertex, what I want you to do, but the axis of symmetry gives us kind of an idea here, right? So let's calculate the vertex, the maximum height of the stream. We need to find the vertex. And do we need the vertex to the full vertex, the x and the y? We need the y, right? Because this says what is the maximum height, not when is the maximum height. If it was when is the maximum height, 1 would be the answer. But what is the maximum height? We actually have to plug this in. Nick, you had a question?
No, I figured it out.
Okay. So negative b over 2a, our equation was negative 16x squared. Was it plus 32x?
No.
Plus 32x plus 5. Negative b over 2a for our vertex gives us negative 32 over 2 times negative 16, or negative 32 over negative 32. Look at that. We got 1. Okay? Now that's not the height, right? That's the x value of the maximum height. So now we got to go back to that equation and plug in 1 for x. Okay? Negative 16 times 1 squared plus 32 times 1 plus 5. 21. Okay? So what is the height of this water? It is 21. Now our original sketch kind of had this stream going kind of like this. Okay? Remember, this is 5. This is 1 second here. We know that at 2 seconds, it's also 5. But at 1 second, the vertex is 21 feet high. Is this a very, now that we know this, an accurate sketch? No, this water is really going like,
Maybe he just has a.
I told
like
you
that.
I was wrong.
Okay? But you said 6.
Maybe
What's
he
it?
could see it from space.
Maybe you
back
got a
in
ladder.
Nathan.
The gravity.
So the more we learn about this parabola, the more that we work with this equation, the more information we gain about what's actually happening here. Okay, is this very realistic situation? No, but I wanted to give you numbers that would work, we could use, that was pretty easy to, But now that we see this, like, okay, well maybe this isn't quite realistic situation, but I'm still using it in context. Maddie.
So realistically, is he kind of like holding the hose up to the sky?
Realistically, this is a very powerful hose. Yes. Yes.
Realistically, I'm not gonna.
Right? Now, letter E. How long will it take the stream to reach the maximum height? What are we looking for here? The x value of the vertex. The x value of the vertex, or the axis of symmetry. We know that we're still dealing with the vertex here because it does say maximum height. But the difference is instead of what is the maximum height, it's how long will it take to get there. We already kind of answered that. It's going to be 1. Right? Because that's the x value of the vertex. Finn?
So wait, that doesn't work with what it says. Like then it says I need to x value of vertex.
Finn, you can write calculate the x value of the vertex if you would like it to be grammatically correct. Yes. And then lastly, how many seconds until this stream of water hits the ground? Keyword here, ground. We're looking for this point right here. What are we finding? I need to what? What value is going to tell us when this hits the ground?
Second. Oh.
Find the x-intercepts. And in honor of Finn, I need to calculate the x-intercepts. Grammar is important, yes. Okay? And there are 2 clues that kind of help us realize we're looking for the x-intercepts here. A, that word ground, I said that was kind of your key word before. And B, in context, if we see where the stream of water hits the ground, we're on the x-axis, right? The height is 0 here. When the height is 0, it's now hit the ground. We're looking for the x-axis, or the x-intercept. Can we use opposite operations here? No. Can we pull out the greatest common factor? No. Anyone want to try and factor this?
No.
Let's quadricides.
No. Yay.
Okay. Negative b plus or minus the root of b squared minus 4 times a times c all divided by 2a.
I know, right? This is so amazing.
Negative 32 plus or minus the square root of 32 squared minus 4 times negative 16 times 5, all divided by 2 times negative 16. Any chance that we look out here and this doesn't hit the ground? No. We see that we've got 2 negatives, which will make this a positive. And if we start with a positive and we add something to it, we're not going to get down to below 0. So it does cross the x-axis twice. Well, it might put a little crater in the ground, right?
So then it could go like.
But then why would it be negative? Because it's now actually below ground, right? I mean, you know, in reality, does this parabola stop at y equals 0? No. In reality, this parabola is going to continue, right? But in context, the water hits the ground and the graph ends, okay? But in theory, if we were to graph this parabola out of context, you would get something that, you know, goes on forever, right? But we're dealing in context here. So anyway, go ahead and solve this out. We'll do I'll do it myself as well on my calculator, wherever it. Thank you. Okay. So the discriminant first, 32 squared minus 4 times negative 16 times 5 gives me 1344.
Hey,
All divided by negative 32. The square root of 1344 does not work out evenly. So our 2 equations are going to be negative 13 plus the root of 1344 divided by negative 32. And our second equation, negative 32 minus the root of 1344 divided by negative 32. So let's see, parentheses, negative 32 plus the root of 1344 divided by negative 32. I get negative 0.14, 0.15 if I round. And then the other one, negative 32 minus the root of 1344 divided by negative 32. I get 2.15. Okay? So first of all, verify that you can get these answers. If you can't get negative 0.15 and 2.15, then let's have a discussion why. Anybody run into trouble? Yes.
Oh, no, I'm not in trouble.
Then save it for now. I want to make sure everyone can do this.
I got I got negative 43 to negative 43.
32 squared minus, so you did plus
I
minus,
got 2.14.
and it's a negative 6, not a positive. There you go. Anybody else? Hold up. No, we're not leaving yet. Don't close your binders. Sit down.
Guys, be quiet.
Folks, I've got prep for the next 2 hours. I'll keep you for as long as I need to. Quiet down. Andrea, go ahead.
The answer has to be 2.15 because it can't be like negative 9.
So now you have to look and remember we're talking about context here, right? Does the graph of this parabola cross the x-axis at negative 0.15? The graph does, yes. If we were to continue this down, it would cross the x-axis on the negative side. But in context, can we go back in time for when the water hits the ground? No. This is what we call an extraneous solution. A solution that mathematically makes sense, but contextually doesn't. Right? Contextually, the only answer that we're going to keep is the 2.15. Because when it comes down here, I put my 2 in the wrong spot, but it's going to come, it's going to hit the x-axis at 2.15 seconds. Okay? We didn't do math for nothing. You still found the x-intercept, but you have to figure out which one it is. Finn.
In all honesty, I mean, considering how powerful that hose is, I wouldn't be surprised if it made a dent in the ground.
Oh, it certainly would, but then you would be below zero. Once you break the plane of the ground, you're now below zero, right? Your homework is to do the next one with the soccer ball. This is due on Monday. That's how you math.
Tuesday.
Tuesday. Thank you.